Okay, today we're going to finish up our continuous improvement talk and talk about preventive and corrective actions. And those are things that we do based on nonconformance or nonconformity or abnormality or defects or low production rate, quality issues, or whatever. Okay. Usually they use a root cause failure analysis to identify those underlying causes. Machine operators can request preventive or corrective action, and they can see they're the ones that first see what the issues are, and then they have to notify somebody what's going on. Preventive action is making sure we take measures so that we don't have any defects or non-conforming parts. And for example, they have production line has size issues, so during non-production time they change out some parts, they get it back into conformance, or actually they get it back to performing well so that there's no parts that are bad. Corrective action is taking place after something has happened to cause a defect or a non-conforming part. For example, if bearings wore out all the way, then parts would be uh, out of tolerance, forcing the machine to be repaired, and that repair is the corrective action. Okay? In order to keep the machine running, you want to use preventive action or preventive maintenance to keep it going, so that way you don't get to a point where you have to shut the machine down. Preventive and corrective action can both eliminate problems, but it's better to use preventive methods because then you have unnecessary downtime. When we're troubleshooting a problem, typically there's this order of steps. First, you identify the symptom, and that could be a quality symptom. Could be something like a defect in the paint or scratches or something like that. But whatever that defect or that quality error is, you need to make sure you identify that, and then gather and review data. Okay, you have to get some data, which is basically measuring what's acceptable, what's not acceptable. Look at your upper and lower limits, etc. Figure out what's happening. What data do you need in order to determine what the cause of this problem is. Okay. Then you observe any indicators. What that means is basically you're comparing to standards. What's happening. Okay, what do we need to do to measure that information? Then we determine the actual fault. To do that, we test, we compare, we judge. Anything that falls outside the limits, requires corrective action. Okay. As an example, machine parts, final diameter is larger than the maximum acceptable, the lathe needs to be repaired. Okay. And always before working on a machine, make sure you provide safety equipment and lockout tag out so no one gets hurt. Then you, step 5, correct the fault. Make sure that the fault has been identified correctly, and then you fix it. And then, you take the next step, which is to document the event. The reason we document is so that we can determine if this happens again, what we did to fix it in the first place. Maintenance people need to be aware of what's happening. So, what was the issue? What did we do to fix it? This is usually called a corrective action report. Okay? And if you look at why machines break down or why there are issues with machines, there's usually two known variances of quality. One's a common, one's a special. A common variance is something that affects all the parts produced. They're going to be minor. If we can't determine what they are and eliminate them, we need to try to look at, doing something to minimize that variance. Okay. Uh, older machines have more variability because they weren't precision machined in the first place. So, we're going to have newer machines that have less variability. Special variances only affect a few parts, and these can be traced back to certain problems, certain issues, certain things that have happened. Special variances can be, like a new person coming on and punching in the wrong number, or voltage issues, or, temperature spikes or something like that. Okay. You have to determine what type of variance you have so that you know what you need to correct. Okay. So we're trying to correct the quality issue. You need to know what kind of variance it is so you know what to do. Now, whether it's a quality issue or whatever, there are two categories of problems that we have. We have critical problems and non-critical. Okay. And critical problems are ones that stop the line immediately. A quality issue that is so bad, you have to shut down and to correct it because you can't have parts going out that are bad. So quality issue, not good, right? If it's no longer in spec, you can't ship it. You have to resolve that problem before you let that machine resume production. Okay? Non-critical problems are ones that don't have an immediate, uh, cause or immediate impact. There are things that could be just maybe it's skipping a cycle, and every once in a while you have to reset something. These are non-critical. They're things that interfere with a production, but they don't necessarily interfere with, maybe the quality. Okay, they're things that need to be addressed, and usually those non-critical problems are things that we can resolve as we do our production. Lots of times non-critical problems are reported and you decide whether or not you want to take action. Lots of times they'll wait and do their action after a certain amount of time when there's a shutdown or something, when there's time to fix it. Regardless, you need to fill out a corrective action report. And that's basically a sheet that says, here's what the problem was, here's what we saw happening, this is when it happened, here's the equipment, what was going on, and what we did to fix it. Okay, and this is something that you have to fill out after you do a corrective action, because it helps other people determine, what maybe in the future they need to look at if it's the same machine. Okay, other things that help a corrective action is you got your failure report data analysis that you use during that corrective action, who performed that stuff, who investigated, any extra theories, any specification changes. All those things are important to a corrective action report because, multiple people, you typically work on quality issues. And when multiple people get involved, they need to share that information. Okay? Responding to a quality problem can be just like stopping the line. Okay? If there's a quality problem and that quality is, lacking, you have to stop the line because you need to resolve that quality issue. It's just like a breakdown. Okay, if you notice something wrong with the product, but the machine's fine, it's, you need to stop and find out what's going on. You tell a supervisor. Okay, lots of machines have automatic stations, automatic gauging stations, measuring stations, and those can stop the line because they'll see that there's just too many bad parts. Okay, so make sure you understand that situation. The line stoppages are not due to breakdowns, they're due to bad quality. Okay, so quality people need to come in and measure. They need to look at what's going on, and they need to put a corrective action in place. All right, that's it for today. Make sure you complete your notes, and we will continue at another time.